Hello. We did the first part of question 16 of 2018 HSC Mathematics paper. Now we continue with part B of the same question. The question goes like that. A game involves rolling two six-sided die. To win the game, the number rolled on the third die must lie between two numbers rolled previously. For example, if the first two dice show 1 and 4, the game can only be won by rolling a 2 or 3 with the third die. Part I, what is the probability that a player has no chance of winning before rolling the third die? Part 2, what is the probability that a player wins the game as a whole? Okay, probably one way of approaching that, one way of approaching it properly is forming a table like this, where we show all the possible outcomes for die 1. So for die 1, I can have any number between 1 to 6, so 1, 2, 3, 4, 5, 6. Similarly, for die 2, I have the outcomes of 1 to 6. Okay. Then in the middle, we write all the possible combinations. So this 1, 1 means the first die is 1 and the second die is 1. First one is 1, second one is 2, and so on. First one is 1, second one is 3, and so on. Okay. Now, the first part of the question is asking what is the probability that a player has no chance of winning before rolling the third die. For this to happen, when you throw the two dice together, they have to be either the same number, because there is no number between two same numbers, or the two numbers should be different only by 1. Okay, I'll underline all those conditions where the two numbers are the same. So here both of them are 1 and 1. So there is no chance for you to, on your third row, to get a number that's between 1 and 1, because there is no such a number. So then all this thing that can happen in the first part deprive us from winning on the third throw. So 1, 1, 2, 1, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, so you've got here 6 cases. Also, if the difference is only 1, so for example, the first die is 2 and the second die is 1, again, there is no number that are lying between 2 and 1, so I have no chance of winning. So 2, 1, 3, 2, 4, 3, 5, 4, and 6, 5. These are all the cases. But also, you have their possibility happening other way around. Rather than having 2, 1, you can have 1, 2. Okay, so then 1, 2 also is similar to that. 1, 2. Rather than having 3, 2, you can have 2, 3. So these also are the cases where we cannot win on the third throw. Okay, so if you count all of these underlined ones, you end up with 16 cases. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 cases that you cannot win when you attempted throwing the first two dice. So and there are 36 cases which can happen altogether. So then 16 out of 36 gives me the probability of no chance of winning. 16 out of 36, which we can simplify to 4 on 9. For the second part of the question, is asking us what is the probability that a player wins the game. Okay, for us to win the game, none of these underlined situations should happen to go to the second round, and in the second round also we should get a number which is between them. Okay, I've created this table to show that situations. So the difference between the two dice when we throw them at the start could be either 2, 3, 4 or 5 for us to win. As I said, anything less than 2, the difference will be 1 and there is no number between them. And we cannot have a difference which is larger than 5 because we have only numbers 1 to 6. Okay? So these are the cases that if the difference between the two numbers we are throwing is 2 or 3 or 4 or 5, we have a chance of going to the next round and winning. Alright, so in how many cases we have the situation where the difference is 2? Okay, the difference is 2, one is 3 and 1, one is 4 and 2, one is 5 and 3, and 6 and 4, and as I said, they can happen other way around, like 4 and 6, 3 and 5, 2 and 4, and 1 and 3. So altogether, we have 8 of such cases. For the difference between them to be 3, like getting 4, 1, 5, 2, 6, 3, so which is 3 cases here, and 3 cases on the other side, like 1, 4, 2, 5, and 3, 6. So altogether, we have 6 cases where the difference between them is equal to 3. And if you continue that for the difference of the two dice which we throw initially to be 4, it can happen in 4 different ways, which are basically this and this, and this and this. And the difference of them to be 5 can happen only if one of them is 6, 1 and the other one is 1, 6. So in 2 ways this can happen. So we have a difference of 5. Alright. Now, then if that is the case for me to have a difference of 2, because it happens in 8 ways here, and I have 36 different outcomes here, then for the case of having a difference of 2, I have a chance of 8 out of 36. Okay, that is for the first attempt, when I'm throwing the 2 dice. Then, when I'm throwing the third dice, which is my second attempt, I have only 1 chance of winning. The reason being that